So here region is not given. That means we have to discuss the global maximum and global minimum value of the function on the entire domain. Your domain of the definition of the function is R. Okay. This function x is a continuous function, e power x is a continuous function, and you know continuous into continuous is continuous. X is a differentiable function, e power x is a differentiable function, x into e power x is a differentiable function. Then we have to find critical points. F of x is equal to x into e raised to the power x. So f dash x is equal to e power x plus x into e power x, that is e power x times x plus 1. So f dash x is equal to 0, e power x into x plus 1 equals to 0. So this implies e power x can never be equal to 0. It is always a positive quantity. So x plus 1 is equal to 0 implies x is equal to minus 1. All right. So now we have to calculate the functional value. F of minus 1 equals minus 1 into e power minus 1 equals to minus 1 upon e. Domain of the function is R. So here that means the interval is minus infinity to plus infinity. Now limit extending towards infinity, x into e power x. Limit extending towards infinity, x into e power x. So infinity into infinity, there is infinity, highest value. So limit extending to minus infinity, x into e power x. So limit extending to infinity, x into e power x, that is extending to minus infinity. So x approaches to minus infinity, e power minus infinity approaches to 0. So this limit takes the indeterminate form, infinity into 0. Okay. This is equal to limit extending towards 0, x upon e power x, e power minus x. Now the limit takes the form infinity upon infinity. This is, sorry, limit extending to infinity, minus infinity. Limit extending towards minus infinity, apply LS rule. Derivative of x is 1 minus e power minus x. Okay. When x approaches to minus infinity, minus x approaches to infinity, e power infinity approaches to infinity, 1 upon infinity approaches to 0. This value approaches to 0. So minimum value is 1 upon e, maximum value doesn't exist. So global minimum minus 1 upon e. Okay. Global max doesn't exist. बुझीगला चैट बॉक्स रे लेख बुझिपारल कि नहीं राजलक्ष्मी श्रुति write in the chat box, is it clear? Okay, next question. Find the global maximum and minimum values of the functions f of x is equal to e power x upon x plus 2. F of x is equal to e power x upon x plus 2. Find greatest and least value. Find the greatest and least value of the function. Solve करिए आंसर को. Yes. 9 server also. मुझे ना comment also. F of x equals e power x upon x plus 2. Okay. This function is discontinuous at x is equal to -2, because at x is equal to -2, the denominator will be 0, right? Except at x is equal to -2, no other points are there where the function is discontinuous and non-differentiable. It is continuous and differentiable everywhere except x is equal to -2. So x is equal to -2 is one of the point where we have to find out the value of the function. Then points of local maximum and local minimum, right? So your domain of the function is r minus -2. Domain of the function is r minus -2. Domain of the function is r minus -2. F dash x equals e power x into x plus 2 1 by e. Okay. E power x into x plus 2 minus e power x upon x plus 2 whole square. Right? So if you take e power x common, e power x into x plus 2 minus 1 upon x plus 2 whole square, right? This is equal to e power x into x plus 1 upon x plus 2 whole square. E power x into x plus 1 upon x plus 2 whole square. So f dash x is equal to 0. F dash x equals to 0 implies e power x into x plus 1 upon x plus 2 whole square is equal to 0. This is possible when x plus 1 is equal to 0. So the value of x is equal to -1. So x is equal to -1 is the only critical point. Now we have to find out the value at these points. F of -1. F of -1 is equal to e power -1 upon -1 plus 2, that is 1. This is equal to 1 upon e. Okay. F of -1 is equal to 1 upon e. Then when x tends to -2, the denominator approaches to 0, numerator approaches to 1 upon e square, so total value approaches to infinity. Limit extending towards 2, -2. F of x equals infinity. What a plus infinity as well, what a minus infinity as well. So -2 plus extending to -2 plus. So -2 plus means it will be negative, minus infinity. Limit extending to -2 minus f of x is equal to plus infinity, right? Then when x approaching to infinity, limit extending towards infinity, e power x upon x plus 2, infinity upon infinity. This is equal to limit extending towards infinity, e power x, which is equal to infinity. Then limit extending towards minus infinity, e power x upon x plus 2. This is equal to limit extending towards infinity, minus infinity, e power x. This is equal to 0, right? So global maximum and global minimum value on the entire domain of the function doesn't exist. Global extremum doesn't exist. Global extremum, DNE, doesn't exist. Okay. Priti, is it clear to you? Smita. Then come to the last part of maxima and minima. That is called practical problems. On maxima and minima. Practical problems on maxima and minima. We'll start with a very simple question so that you can understand the concept. Okay. Find two numbers x and y. Find two numbers x and y such that x plus y equal to 15 and x y square is maximum. Find two numbers x and y such that x plus y is equal to 15 and x y square is maximum. तो यही टाइप रो क्वेश्चन रे तमर देखो एटा मैक्सिमम कि मिनिमम कि ग्रेटेस्ट कि लिस्ट एम सब लिखाई थो जोटा मैक्सिमम कि जोटा मिनिमम कि जोटा ग्रेटेस्ट कि जोटा लिस्ट देथो सेटा को हमें फंक्शन बोले अज्यूम करबा ताले एटा p नै जबा p is equal to the product of two quantities p is equal to x into y square. Now the value of p depends upon x and y. ताले it is a function of two variable. हमें जो कैलकुलस पढ़िले मैक्सिमम इट इज फॉर फंक्शन ऑफ सिंगल वेरिएबल फंक्शन ऑफ वन वेरिएबल फंक्शन ऑफ वन वेरिएबल वन इंडिपेंडेंट वेरिएबल ओके तो एठी हमर काम कोन ना प्रथमे ई जो फंक्शन ऑफ टू वेरिएबल को हमें फंक्शन ऑफ वन वेरिएबल कन्वर्ट करबा कन्वर्ट करिया पे डाटा एक्सप्लिसिट थाई पारे डाटा इम्प्लिसिट थाई पारे एठी डाटा एक्सप्लिसिट अछि माने गिवन डाटा क्लियर डाटा अछि तो y is equal to 15 minus x y is equal to 15 minus x. So p is equal to x into 15 minus x whole square. Okay. Now p is a function of single variable. To find the maximum and minimum value, we can differentiate. To find the maximum and minimum value, we can differentiate the function. So this is equal to x into 225 plus x square minus 30x. This is equal to x cube minus 30x square plus 225x. X cube minus 30x square plus 225x. So for extremum dp upon dx will be 0. So dp upon dx equals 3x square minus 60x, minus 60x plus 225. dp upon dx is equal to 0. dp upon dx equals to 0. This implies 3 times x square minus 20x plus 75 is equal to 0. Implies 3 into by middle term factorization x minus 5 into x minus 15 equals to 0. Implies x is equal to 5 or x is equal to 15. X is equal to 5 or x is equal to 15. Then we have to find the, for confirmation, we have to take the higher order derivative. d square p upon dx square. d square p upon dx square is equal to 6x minus 60. d square p upon ds square d square p upon dx square at x is equal to 5 will be 6 into 5 minus 60, 30 minus 60, which is equal to minus 30. Okay. So this d square p upon dx square less than 0. Second derivative, even order derivative less than 0. That means x is equal to 5 is the maximum, local maximum point. So maximum value is obtained when x is equal to 5. If x is equal to 5, then what is the value of y? The value of y is 15 minus 5. 15 minus 5 equals to 10. Okay. So the product x y square is maximum when the value of x is equal to 5 and y is equal to 10. And the maximum value of the expression will be 5 into 10 square, 5 into 100. 5 into 100 is equal to 500. So maximum value is 500. ବୁଝିଗଲା ପିଲେ? ବୁଝିପାରିଲ? Is it clear to you? Chat box ରେ ଲେଖିକି ଜଣାଅ ବୁଝିପାରିଲ କି ନାହିଁ? Just a minute, guys. 1 minute pause नबा. Next question. Determine a rectangle of area 25 square units. Determine a rectangle of area 25 square units which has minimum perimeter. Determine a rectangle of area 25 square units which has minimum perimeter. Okay. Determine a rectangle of area 25 square units which has minimum perimeter. Try to solve it. Determine a rectangle means we have to find out the length and breadth of the rectangle. Let x be the length and y be the breadth. It is given that area is 25 square units. Xy is equal to 25. So, and perimeter is equal to twice of length plus breadth, twice of x plus y. So, y is equal to 25 upon x. So, perimeter P is equal to 2 into x plus 25 upon x. So, dp upon dx is equal to 2 into 1, derivative of x is 1, minus 25 upon x square. So, for extremum value, dp upon dx equals to 0. This implies 2 into 1 minus 25 upon x square is equal to 0. This implies x square minus 25 equals to 0. X square minus 25 is equal to 0 implies x is equal to plus or minus 5. Okay. Then apply the second order derivative test. D square p upon dx square equals to 2 into derivative of 1 is 0. Derivative of minus 25 by x square is equal to plus 50 by x cube. Okay. dp upon dx. So d square p upon dx square at x is equal to 5 equals 100 by 5 to the power 3. This is equals 100 by 125 greater than 0. So perimeter is minimum when x is equal to 5. Perimeter is minimum when x is equal to 5. If x is equal to 5, then y is equal to 5. So when x is equal to y is equal to 5, when length is equal to breadth is equal to 5, then the perimeter is minimum. Did you understand, guys? Write in the chat box whether it is clear to you. Next question. So that the semi-vertical angle cone, so that the semi-vertical angle of a cone of given slant height is tan inverse root 2 when its volume is maximum. So that the semi-vertical angle of a cone of given slant height is tan inverse root 2 when its volume is maximum. এটা প্লেট কি নিজে সলভ করে আপনি চেষ্টা করো। सॉल्व କରିପାରୁଛ ପିଲେ? The cone, okay. Let r be the radius of the height, h be the height of the cone, and this one is the slant height. Let it be equal to L. Given slant height means the slant height of the cone is fixed. So continuously the radius and the height of the cone is changing. Okay. So when the question is when the volume of the cone is maximum, then this angle, let the same vertical angle be theta. When volume is maximum, then theta is equal to tan inverse root 2. Okay. Volume V is equal to 1 by 3 pi r square h. Okay. Now volume V is dependent on r and h. There are two independent variables. So now first of all we have to reduce the two variable into one variable. You see, in this is suppose A, this is O, this B. In the triangle AOB, sin theta equals to R by L. This implies R equal to L sin theta and cos theta is equal to H by L. So H is equal to L cos theta. Okay. Now both the variables R and H are dependent on a third variable, theta. Now volume V is dependent on theta. V is equal to 1 by 3 pi. What is R? R is equal to L sin theta. R square will be L square sin square theta into H will be L cos theta. This is equal to 1 by 3 pi L Q sin square theta into cos theta. So dV upon dH equals 1 by 3 pi L Q into derivative of sin square theta is 2 sin theta into cos theta into second function cos theta plus sin square theta into derivative of cos theta is minus sin theta. So dV upon d theta, sorry. dV upon d theta equals 1 by 3 pi LQ into, we can take 2 sin theta as common, 2 sin theta into cos, no, sorry, sin theta, not 2 sin, sin theta into 2 cos square theta minus sin square theta. So dV upon d theta is equal to 0. dV upon d theta equals to 0. This implies 1 by 3 pi LQ sin theta into 2 cos square theta minus sin square theta equals to 0. So quickly note it down. I will use the next page. लिखिदेल प्ले नेक्स्ट पेज मूव करबा So 1 by T pi LQ sin theta into 2 cos square theta minus sin square theta is equal to 0. So these are the constant quantities, they can never be equal to 0. Either this one is equal to 0 or this one is equal to 0. So sin theta is equal to 0 implies theta is equal to n pi, which is impossible. If you take n is equal to 1, it will be pi, not possible. The semi-vertical angle can never be equal to pi. If you take n is equal to 0, then semi-vertical angle is not equal to 0. If the semi-vertical angle is 0, then it is not a cone. Okay, the only possibility is 2 cos square theta minus sin square theta is equal to 0. 2 cos square theta minus sin square theta is equal to 0. This implies sin square theta is equal to 2 cos square theta. This implies sin square theta upon cos square theta equals to 2. So tan square theta is equal to 2. Tan square theta is equal to 2. This implies tan theta is equal to root 2. Theta is equal to tan inverse root 2. So semi-vertical angle can never be negative angle. Okay. So from this it is clear that when the volume of the cone is maximum, then the semi-vertical angle, this angle is tan inverse root 2. I hope it is clear to you. बुझी पारले पिले सब तमरो आज डिफरेंशियल कैलकुलस रो मैक्सिमा मिनिमा कंप्लीट हे गेला तापर हमें आरंभ करिबा कोन इंडेफिनाइट इंटीग्रल सेपरे तमर चलथिबो डिटरमिनेंट एंड मैट्रिक्स ठीक है पिछले integral calculus will start in the next schedule. आज आउ पढिबानी एति पढिबा हैला तुम भी 3 घंटा बसलेनी बोर हे जवणी तुम्ही आज सब बुझियला श्रुति राजलक्ष्मी सुचिस्मिता सुप्रिया ओके क्लास ला सब रेगुलरली अटेंड करो सब किछि बुझी परिबो ठीक ठाक आउ बेसिकली इंटीग्रल कैलकुलस जमा गोटे क्लास मिस करबोनी कारण मिस कले अलग क्लास को बुझिया को असुविधा हो